For our last practice example, we are going to run a two-way repeated measures ANOVA. So to refresh your memory from the lecture, a two-way repeated measures ANOVA is when we have two independent variables that are within subject factors, both being nominal data, and our dependent variable, we only have one, and it should be ratio or interval data. For the description of the data set that I've given you, researchers are interested in seeing if interval training has an effect on heart rate at different stages of exercise. So right off the bat, we kind of get a glimpse of what our independent variables are. So seeing if interval training has an effect, right? So interval training or some type of training program is likely to be an independent variable. Effect on heart rate, which indicates or kind of suggests that heart rate is our dependent variable. At different stages of exercise, so stages or time points might also be another independent variable. During the visit, 10 participants were asked to run continuously on a treadmill for 20 minutes at their preferred running speed. During the second visit, the same participants were asked to perform 1 minute of running at their preferred running speed, followed by a 1-minute rest period. Subjects alternated between running and resting for 20 minutes. Heart rate was monitored in beats per minute every 4 minutes for each session. So this tells us our interval training. We either had continuous running during session 1, or we had our interval running where they were running 1 minute on, 1 minute rest during the second session. So the type of training program or type of training, it doesn't matter how you word it, that has two levels. Okay, so continuous running and interval running, or continuous training and interval training. The other measurement that we are looking at was different stages of exercise. So it said that each bout of exercise was 20 minutes, and heart rate, which is our dependent variable, was collected every 4 minutes for each session. So that means 20 divided by 4, we should have 5 different time points at which we collected heart rate. And then on top of that, we should have that multiplied by 2. So each subject should have 10 heart rate measurements as a whole. 5 from the continuous training session, and then 5 from the interval training session. In our spreadsheet, we are going to organize our data so that we can run a two-way repeated measures ANOVA, since we have 2 within subject independent variables and 1 ratio dependent variable. We're going to assume that our data are normally distributed and that we have a level of confidence of 95%, so an alpha of 0.05. I'll run you through how to actually set up the test, and then we'll interpret the results. For two-way repeated measures ANOVAs, we don't calculate effect size, rather we just use the partial eta-squared value that is in the output that SPSS generates for us. So we'll look at the effect size for each of the main effects, as well as the simple main effects for the interaction between our time and training program variables. The last thing we'll do is create a bar graph so that we can represent the mean differences between training programs within each time point. We'll add error bars to each of our series so that we can see both the measures of central tendency and variability on our graph. So for all of the steps that I'll be running through, feel free to refer to the Module 8 Part 2B PowerPoint that goes through all of the screenshots and different scenarios that you might have. So while the example we run in this one may be applicable to this example, you might have something different that shows up for your other task example of a two-way repeated measure ANOVA. So if all else fails and the video doesn't cover what you're looking for, you can always refer back to the PowerPoint, and hopefully that will help you piece some stuff together. So let's go over to our data. We have a subject column, so we have 10 people. Each subject should have 10 measurements, right? Again, 5 in our continuous training group, 5 in the interval training group. Each of those 5 measurements represents a different time point. Now, the way that we have the data set up right now, we could paste it into SPSS. However, you're only allowed to take one variable label with you. So having 4-minute, 8-minute, 12-minute, 16-minute, and 20-minute labels repeated twice isn't the most ideal thing. So what we can do is we can abbreviate continuous and say this is con 4. And then we have a con 8, a con 12, con 16, and a con 20. So each of these would represent the time points for our continuous training. We then can do the same thing for our interval training, so INT. And I'm now realizing that these abbreviations are the same as what I used in the example in your PowerPoints, which is kind of funny because they mean different things. As long as you understand what your abbreviations are, I couldn't care less what you put down. But once we rework our data so that each column has a unique name, we can then copy both our data labels as well as all of the measured heart rates. We'll copy that into SPSS. So I have a fresh new data set ready for us. Again, each row should have 10 measures, so you can use that as a double check, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. In the variable view, again, the default for your measures should be scale, but just in case it's not, you can change all of these to scale or not and just leave it to chance. Sometimes it works great. Other times I've been screwed over by SPSS, so can never be too careful. Okay, so once your data view looks like that, we can run our repeated measures analysis by going to Analyze, General Linear Model, Repeated Measures. We'll have a very similar setup to our one-way repeated measures ANOVA, where we are identifying each of our independent variables. So let's say we put in the type of training first, and that has 2 levels. And then we also had our time points, and we had 5 levels of that, right? 4, 8, 12, 16, and 20. The measure name that we have collected is heart rate. Usually this measure name box is more helpful when you have multiple dependent variables, but I like to put it there just in case. And then we click Define. And that'll bring up our repeated measures dialog box. So this is a little bit more complicated than the sample output that I gave you guys in the PowerPoint, but in the parentheses up here, you can see that the naming convention for each of these spots is the training program followed by the time point. So again, you make up what your labels are. I generally like to make it so that my setup is easy, so I can just copy all of my variables and insert them straight into the box. So the way that I have training and time set up right now is perfectly lined up with how my data are organized. But just so you get a better sense, 1, let's say, is our continuous training group, and then 2 is our interval training group. Okay, so each 1 and 2 have a set of 5 time measurements, which is after the comma, associated with the session. So let's say 1 is our first measurement at 4 minutes, 2 is our second measurement at 8 minutes, 3 at 12, 4 at 16, and 5 at 20. So if I have a label 1, 1, that should indicate that I have my continuous training at my 4-minute time period. 1, 2 would be continuous training at my 8-minute time period. Okay, and then so on and so forth. It basically goes down the list. The one thing you want to be careful about is if maybe you put time in first, then you're going to have 2 sets or 5 sets of 2 because time would have been listed first and then training. So the order that you define your variables does matter because that ends up being the order they show up as in the parentheses here. Okay. Once you input all of your variables, we can set up our post hoc tests. So I want the main effects, I want pairwise comparisons calculated for both the main effects of training and time, as well as the interaction. So I'll stick those into the display means for box and compare my main effects using a Bonferroni adjustment. For options, I'll choose the same ones that I chose for my one-way ANOVA, so descriptive statistics and estimates of effect size. And then the last thing we do in here is we go to paste. This will open up a syntax window so that we can adjust the pairwise comparisons for the interaction effect. Okay, so in our output, or syntax window, we can see that our pairwise comparisons are set up for each of the main effects of our independent variables. And then we have it started for our interaction effect. So I'm going to start typing compare. I'll put a parentheses. And then the interesting thing about when you do a repeated measures ANOVA is that because each column represents a variable, SPSS, the autofill function, will only recognize the labels that you have in your variable columns. So when you type in your independent variable, it has to match exactly what shows up here. Otherwise, the syntax screws up and things go haywire. So I'm going to compare training using Bonferroni adjustment. So this is fairly similar to last week. Okay. I'll enter down to the next line of code, and then I'll copy and paste and change training to time. Okay, so now I have my simple main effects tests, or the pairwise comparisons for my interaction effect set up appropriately. I can go to run all, and that will give me my output. First things first, let's relabel this practice 3. I'll get rid of the notes section. We can see our within subject factors up here have our training conventions, or the labeling conventions that we used for training. So again, 1 is representing our continuous training, 2 is representing interval, and then our time points are associated 1 with 4, 2 with 8, 3 with 12, 4 with 16, 5 with 20. Again, when you go through your output, because repeated measures only labels by numbers, if you forgot how you input your data, you can always go back to this table. It saved my butt so many times from having to go back and redo the ANOVA. So highly recommend, if you forget, just come back to this table. Our descriptive statistics are listed here, so we can see what the means were, what the standard deviations were, and how many people were collected in each group, which should be 10 because we just repeated the same 10 measures for every single collection. The next table is our multivariate tests, which I'm going to take out. And then following that, we have Modgley's test of sphericity, where we can see we've got a row for our training group, a row for our time points, and then the interaction between training and time. Similar to the example that I gave you guys in class or in the lecture video, the p-value for training is going to be non-existent in the sphericity table because training only has 2 levels. So when you have a 2-level independent variable, you end up getting a Mauchly statistic of 1, which indicates perfect sphericity. So because there's no p-value and we only have 2 levels, we are going to assume that we have met sphericity for the training group, or for the training variable. The p-value for time is 0.088, which is larger than 0.05. So this is indicating that we have met sphericity for our time points, which means we can read the sphericity assumed row for time in our ANOVA table. The last p-value we assess is for the interaction, which we have 0.044. That is less than 0.05. So this indicates that we reject the null hypothesis for sphericity, and the variances of the differences between all of our, let's say, levels of training across all the time points are not equal to each other. Okay. When this happens, or when we violate sphericity, we then look at our greenhouse geyser epsilon value. We see here that the epsilon value is 0.711. The criteria to use the greenhouse geyser adjustment is that this value has to be less than or equal to 0.75. We made it, so because this value is less than 0.75, we'll use the greenhouse geyser adjustment in our ANOVA table for the interaction effect. So then we can go to our test of within subjects effects. Right off the bat, I'm going to go ahead and double click into my table. I'm going to highlight the p-value for my training programs because we assumed sphericity. We also assumed sphericity for time, so I'll go ahead and highlight the p-value in that row. And then for our interaction effect, we said we were going to use the greenhouse geyser adjustment since our epsilon value was less than or equal to 0.75. That leads us to a p-value of 0.033. So each of these p-values would be reported as the main effects of the corresponding variable that is in our ANOVA table. So an interpretation of the p-value for our training program is that the type of training program has a significant effect on heart rate, or you could say heart rate in continuous training is significantly different from heart rate in interval training, etc., etc. For time, since we had multiple time points, sometimes it's just easier to say like there are significant differences in heart rate for each of the time points, or for at least one pair of the time points that were analyzed. Okay, and that had a p-value also less than 0.001. The interaction effect we can see between training and time is less than 0.05. So we would report the p-value as equal to 0.033. It's less than 0.05, so we reject the null hypothesis for our interaction effect. And that would mean we have an interpretation of there is a significant interaction between the type of training program and the time at which heart rate is collected. Okay, so we have 3 significant main effects. Thus, we need to look at post hoc tests or pairwise comparisons for each of our independent variables. Technically speaking, we don't really need to look at pairwise comparisons for our training program because training only has 2 levels, and thus the pairwise comparison should be redundant with what we get in the ANOVA table. but we'll look at them anyways, just so we can see what they look like. In here we have training 1 as our continuous running, training 2 as our interval running. We can see the mean difference was calculated by doing continuous minus interval. So having a negative mean difference indicates that our interval, or the mean heart rate for our interval training, was greater than the mean heart rate for our continuous training. In our table, again, you can see the redundancy in the p-value. So we get a p of less than 0.001, which indicates there is a significant difference between continuous training and interval training for the heart rate measurement. We can then go to our pairwise comparisons for our time variable, in which case 1 was equivalent to 4 minutes, 2 was equivalent to 8 minutes, 3, 12, 4, 16, and 5, 20. If the numbering thing messes with your head, when you double click in your table, you can actually change the values here. So if instead of 1 you want, if instead of 1 you want to list a 4, and we're not going to make it that large, it's a little excessive. Okay, if you wanted to make each of these their respective, like you can even add units if you want to. All I'm doing is double clicking on the number and then typing and apparently SPSS is having a hard time today, so there's that. I think as I'm doing the keystrokes, it helps if you click on the cell and then double click on the number, and that tends to make it not freak out. And then for formatting, I have to fix that. Okay, so for the times here, you'll notice that when you click on 1, 2, the rest of the 2 labels will highlight. So that's the nice thing about this, is that 2 represents 8 minutes. As soon as I change that, it changes everywhere else in the table. So actually changing the labels on this, if it helps visually, honestly, I would probably do it. Especially when you have more than 3 variables, sometimes the tables can get kind of messy. So once we have our variables reset, and we can change 1 to 4 minutes, then we can look at our significant pairs. So in our comparison to 4 minutes, we have significant differences between all of the other time points and 4 minutes. So I'm going to highlight those. Okay. And I actually highlighted one that crossed over into 8 minutes, which I'm going to unhighlight because that is a redundant pair. I also, if I'm looking in my comparisons with my 8-minute time point, I'm really wanting to look at 8, 12, 8, 16, and 8 and 20, since I've already looked at the difference between 8 and 4. And I can see that all of these pairs are significant, so I'll highlight those. For 12 minutes, we have significant differences between 4 and 12 and 8 and 12. However, we've already identified those pairs up here, so we can kind of ignore those and look at the last 2 values, which would be looking at the differences between 12 minutes and 16 minutes and 12 minutes and 20 minutes. Between the 2 of those values, we only have 1 significant pair, which is between 12 and 20 minutes. So I will highlight that one. Under 16 minutes, we've looked at all of the potential pairs except for 16 and 20 minutes. So that 0.017 is less than 0.05, which makes it significant. And by the time we get down to our last section, if we have highlighted a significant pair at 20 minutes with each of our previous time points, we don't really need to look at this one because we've already accounted for those pairs in kind of the higher levels up here. So once we have our pairs identified, I then could list them out, right? So some of the ways you might want to write this is that you organize it by the first column of time. So all time points are significantly different from 4 minutes. 8 minutes was significantly different from 12, 16, and 20 minutes. 12 minutes was significantly different from 20 minutes. And 16 minutes was significantly different from 20 minutes. Now, recall that all of these significant pairs are with regards to the dependent variable heart rate. So the significant differences are in the heart rate measure between each of the time points that were listed with the p-value less than 0.05. So we've got our two main effects of our independent variables covered. Now we can go to the pairwise comparisons for our interaction effect. This first one, I'm going to change the labels on these again because I think it helps. If you're Gucci, don't worry about it. But what I will say is make sure that when you are writing your interpretations, you use the variable name and not the number. So if you're like, oh, there are differences between time points 1 and 2 and time points 3 and 5 or whatever, I've done so many outputs in this class, I don't remember which one is. So make sure you interpret everything in terms of the levels that we've identified for each variable. For my training, I'm just going to change this to continuous. My 2 was interval. Okay. So now I have all of my labels set up, and then I can start identifying my significant pairs. Really, all we're looking at is the difference between continuous and interval training. So for each of our levels of time, we're only going to highlight maybe one pair because the other one is redundant with itself. So we do have a significant difference between continuous and interval training at 4 minutes. We have a significant difference between continuous and interval training at 16 minutes. And that looks about it, right? 0.553, 0.138, and 0.057 are all greater than 0.05, so they are considered non-significant. Okay, so one way that we could report our results is that heart rate in continuous training is significantly different from heart rate in interval training at 4 minutes and 16 minutes of exercise. Something like that, okay? We could also say this as all differences in heart rate between continuous and interval training programs are not significant except for at 16 minutes and at 14 minutes. Okay, lots of variability on how you can interpret these. Again, as long as you identify the significant pairs, you are fine. From there, we have one more set of pairwise comparisons to look at. And that is looking at the differences in time points, or differences between time points within our training. So I'll label continuous and interval. And then my time point 1 was 4 minutes. Time point 2, 8 minutes. 12 minutes. Okay. We'll just gradually change all of these. Oops. And the last one. There we go. There we go. Okay. So when I look at the significant differences between my time points in the continuous training, let's start just within time point, or just looking at the differences of time points in comparison to 4 minutes. So kind of spanning this area here. I notice that all of these time points are significantly different from 4 minutes. So I'll highlight those. I then have my differences between 8 minutes and all of the other time points. I've already accounted for this one, so really I'm just looking at these last 3. And I notice I have 2 time points that are less than 0.05. So 8 minutes is significantly different from both 16 and 20 minutes with regards to heart rate. Differences at 12 minutes, I can see these are my redundant ones that I've already covered in these first 2 areas. 12 and 16 minutes are definitely not different from each other, but 12 minutes is significantly different from 20 minutes. We have a p-value less than 0.05 there. Moving down to 16 minutes, really the only comparison we haven't looked at with 16 minutes so far is at, or looking at the comparison between 16 and 20 minutes. So I'll highlight that one. You'll notice 16 is significantly different from 8 minutes, but we did already get that up here. And then the last comparison of 20 minutes and all of our time points, we should have caught all of them by the time we get to this one. So you can double check, but I'm pretty sure, yeah, at time point 20, we got the differences for every single one of those. So that's the first part of the table. These would be significant pairs in the continuous training program. So we could interpret this as all time points are significantly different from 4 minutes. 8 minutes was significantly different from 16 and 20 minutes. And 12 minutes was significantly different from 20 minutes within the continuous training program. We would then add our interpretations of our differences between time points within the interval training. So again, we look at our section of 4 minutes in comparison to all the other time points, and we notice we have all significant differences. For 8 minutes, we can see we have significant differences with 12, 16, and 20. Again, we've already accounted for 4 and 8, so we can skip that one. For 12 minutes, we're mainly looking at the differences between 12 and 16 and 12 and 20. Both of those values are greater than 0.05, so we don't have any significant differences there. And then by the time we get to 16 minutes, we're mainly interested in the comparison between 16 and 20, which is also not significant. By the time we get to our last group, we should have looked at all of these comparisons up in this area. So we can conclude that in the interval training program, 4 minutes is significantly different from all other time points, and 8 minutes is significantly different from 12, 16, and 20 minutes with respect to heart rate measurements. Okay, so that covers our pairwise comparisons, p-values, and interpretations. The next thing you are requested to report is the effect sizes. So we can go back up to our test of within subjects effects table, and we can draw our attention to training and time. These are the two independent variable main effects, and we want the partial eta squared that is associated with the assumption that we met. So we met sphericity for both of these, which means that we can use the effect size for both of these sphericity assumed rows. In this case, our effect size for training is 0.889, which is considered a large effect size, and the effect size value for time is 0.929, also considered a large effect size. For the interaction effect, we don't get the partial eta squared from this table. Rather, we get it from the multivariate table underneath our pairwise comparisons. So I skipped to number 3 in my output for the interaction between training and time, where we were looking at the differences between our training programs within our time points. So again, in the multivariate test, you'll probably have to change the time points for everything to make sense, unless you feel comfortable using the number labels that automatically get put in the output. I like to do this as like a double check, so there we go. Okay, so we've inserted our time points. The other thing I like about this is I can drag it around, right? So if I wanted to scroll back up in my output and I forget, which pairs were significant, because I ask you guys to report the effect sizes for the significant interactions only. We know that we had a significant interaction between, or a significant difference between continuous and interval training within the 4-minute time period. So in this multivariate test, under the 4-minute time period, I can find the effect size for the differences between my training programs, listed as 0.631, which is considered large. My other significant difference was between continuous and interval training at 16 minutes. So I can go back to my multivariate test at 16 minutes, and I can choose my effect size to report as a large effect size. Okay. So again, the interpretations of the effect size is that it's a large effect size for the differences between the training programs within the time point that is listed in the multivariate test. For the other example, or the other interaction effect we looked at, we had comparisons of time points within each training program. So if we go down to our multivariate tests, this one's going to be kind of on the easier side. We had significant pairs within the continuous grouping, so that means we just report one effect size for all of our significant differences. The same thing happened for the interval training, so we would report both 0.986 and 0.982 as the effect sizes for the differences between time points within our continuous training and interval training, respectively. That pretty much does it for the output. So I'm going to minimize this. I'll minimize my syntax, and I'll minimize my data. And what we can do from here is create our bar graph. So I'm going to reorganize this just a little bit, where I do, let's see, I think I want to do my time points on the top, so this would be 4 minutes, 8 minutes, 12 minutes, 16 minutes, and 20 minutes. And then I'll have a row for continuous and a row for interval. In these cells here, I then can calculate the means for each respective group. So this first table is going to be my averages, which I can insert a row if that helps keep you guys organized. Okay, and I can simply calculate my average for continuous at 4 minutes, my average for interval at 4 minutes, and then I can copy these across. I can then create a fairly similar outline of a table, but instead of averages, I'd be looking at my standard deviations. And then I can use my stdev function, again calculating the respective time points with the training session. Copy those across. I'm going to reduce my decimals to 2 places. And then from here, we just copy or highlight all of the means, including the data labels. And that will allow us to have our labels automatically input into our graph when we insert it into Excel. Now, my axis titles. Okay, this one is going to be time points, and I specified in the instructions that I wanted the difference between the means for our training programs within each time point. So the within portion is going to be what your x-axis is. The between part is going to be the bars or the legend, if that helps you. Okay, so we could list this as time, we could list this as the stages of exercise, which is kind of originally how we phrased it. Our y-axis would be representative of the dependent variable, which is heart rate, and that was measured in beats per minute. You can come up with a nice fancy chart title. And all we have left to do is add the error bars. I'll do continuous training first. So click OK. We can do the whole custom value thing, and then I'd highlight the standard deviations for my continuous training for both the positive and negative error values. And then for my interval training, I can add error bars. Also specifying a value as the standard deviation for the interval training. Paste that, press OK, and then I can move my graph over here. And there we have it. Right? You would put in a nice little chart title, and this would reflect the differences between our training groups within each time point. Now, again, I showed you guys last week that when you click in your graph, if for some reason you set up this averages table incorrectly or it came out the other way around, you can always do switch rows and columns. And then this would be a representation of the differences between time points within each training program. Just keep in mind, if you have already set up the other components of your graph, that you'll have to change the labels so that they appropriately match what your graph is showing. So Once you have this formatted appropriately, you can copy and paste it into your answer sheet, and then the last video we will go through is going to do an overview of all of the tasks, which are basically repeats of all of the practices that we just did.